everybody. So today I wanted to go over these notes with you, understanding geologic history. I know that I posted these on Google Classroom about a week and a half ago for you all just to look over on your own. And then I also asked a discussion question about which fossil you thought was the most interesting and why. But I wanted to record myself just going a little bit more in depth with these notes. So my first question for you all was to remember what were our four major segments on the geologic time scale. So that is what we spent that entire week that we returned from track out talking about. Hopefully you remember that our first unit of time was our Precambrian time. And then we had our Paleozoic era, our Mesozoic era, and we currently live in the Cenozoic era. So hopefully you remember that. Thinking about geologic time, scientists use many different things to study geologic time. Some of those artifacts would be ice cores, tree rings, sedimentary rock, faults, igneous rock formations, and fossils. So through the rest of this video, we're going to go over all of these different artifacts a little bit more in depth. Let me also take this opportunity to remind you, you have a hard copy of these notes in that folder that I gave you the last day of school. If you still have those notes, you can go ahead and fill in all of these blanks here. That way you have a hard copy of them. Otherwise, if you happen to lose your folder, just remember that you can find a digital copy of these notes on Google Classroom, okay? So first, we're going to start with ice cores, which I think are pretty cool. Cool, ice, get it? So ice cores are cylinders of ice that are drilled out of glaciers and polar ice sheets. So glaciers, polar ice sheets, we're thinking obviously about very cold places like Greenland, maybe Antarctica, northern Russia. So ice cores play an important role in helping scientists gain an understanding of Earth's history because they show us how Earth's climate has changed over time. Here you can see a picture of a couple of scientists working with a drill to drill out an ice core from a big glacier. So we can see that this machinery is pretty massive, and it takes obviously a lot of work and a lot of intelligence to obtain those. So when snow falls, it carries compounds that are in the air at the time. In areas where temperatures are rarely above freezing, this builds up layer upon layer of compacted snow, which becomes ice. So if it's never above freezing, then the snow is never going to melt. Instead, it's just going to get compacted and compacted and compacted into ice. And you can see in this bottom right picture that actually forms different layers. So almost like the sedimentary rock that we're going to talk about in a little bit, scientists are able to look at these different layers and see what the atmosphere was like when that snow originally fell, which is pretty cool. So things that scientists might look for, they might look for carbon dioxide in the air at that time. So remember that carbon dioxide is a greenhouse gas. So if we had more carbon dioxide in the air, then the temperatures were probably a little bit warmer. If we had less carbon dioxide, then Earth's climate was probably a little bit cooler. Scientists have also looked for sulfuric ash, which is from volcanic eruptions. So if scientists can see that there's a lot of sulfuric ash in one layer, then they know that probably at that time period, there was a lot of volcanic activity somewhere around the Earth. So if you want to pause my video and then click on the notes, this bottom link, it's just a short little video clip about ice cores that you're more than welcome to watch. It kind of interviews a couple of different scientists and who work with ice cores, finding ice cores, or drilling ice cores. So it's an interesting video. Okay, our next artifact is tree rings. So when you cut a tree trunk in half, we see rings. So here we have a picture on the right of a tree trunk that has been chopped, and we can see all of the different circles. Each of those circles represents a year of growth. So rings vary in size depending on annual weather patterns. So if a ring is thicker, like right here where you see my mouse, that ring is pretty thick, which means that there was a lot of growth that happened in that year. So that tree probably had limited competition for sunlight and nutrients, and it probably had a lot of rain. When we have thinner rings, like right here where my mouse is, that means the tree grew less in that year, which probably means that it might have had more competition. It probably had less rainfall. If we see a bunch of rings like that in a row, maybe that was a time of drought. We call this dendrochronology. So let's remember that our root word dendro means tree and chron means time, and then ology, of course, is the study of. So dendrochronology literally means the study of tree time. Isn't that pretty cool? So you have one of your first activities for this week is actually about dendrochronology, and in that activity, you learn that one ring actually is only half of a year of growth. So if you look at this picture, we see each ring alternates in color. We have a white ring, a dark ring, a white ring, a dark ring. That's hard for me to say. So the white ring is really fast growth, which happens in spring and summer. And then the darker rings are the slower growth, which happens in fall and winter. So actually, like right here, this white ring and this dark ring together, that's 1 year of the tree's life. Okay, if you want to pause this notes video, you can click on this link below and watch the short little video clip about dendrochronology. And then we will move on to sedimentary rock. So sedimentary rock is rock that has formed through the deposition and solidification of sediment, especially sediment transported by water, ice, or wind. So if you think back to elementary school, maybe 6th grade, you learned about different types of rocks. We have sedimentary rock, igneous rock, and metamorphic rock. So we're going to focus on sedimentary rock first because this type of rock makes up 75% of the rock on Earth. So when we think about that definition, rock that has formed through the deposition and solidification of sediment, that word deposition means that that sediment was deposited somewhere. So the sand, the mud, whatever it is that we're talking about has all been brought into the same location and then solidified, which means turned into a solid. So if we look at this picture down here, you can very clearly see stripes in the rock or different layers in the rock. So each of those layers might have been made by a different type of sediment. And that sediment is deposited all into the same place, either from water, like rivers, lakes, oceans, all of that moves sediment. Ice, as ice melts or as glaciers melt, it can move the earth underneath with it. It can move that top layer of dirt or mud or whatever. And also wind. So as the wind blows, it could carry sand or mud or dirt, something can carry it all to the same location where it will then solidify and form sedimentary rock. If you want to pause this video and watch the short little clip on sedimentary rock, please feel free to do so. So continuing on with sedimentary rock, they form in layers, like we just said, with the oldest layer at the bottom and the youngest layer at the top. So that right there is our law of superposition. If we think about our root word for super, it means on or above. So law of superposition, we're talking about the rock layers that are on or above each other, which really makes sense, right? So this layer at the bottom had to have been there in order for all these layers to form on top of it. If you think about it, it really doesn't make sense any other way. So oldest is at the bottom, and then as time goes on, sediment forms on top of that layer, and then that layer, and then that layer, and then that layer, until you get to the top of the rock. So law of superposition in any undisturbed sequence of rock deposited in layers, so sedimentary rock, the youngest layer is on the top and the oldest is on the bottom, each layer being younger than the one beneath it and older than the one above it. If you would like to pause this video and watch this clip, please feel free to do so. Law of superposition is a very important concept for our evolution of landforms unit, so I want to make sure that you really have a good understanding of this. You have several activities, I think 4 of them this week are on law of superposition, so you'll get a lot of practice with this week. So take a minute on your own when you're looking at this picture, thinking about the law of superposition. Which color rock layer would you say is the oldest, and which would you say is the youngest? If we think back to law of superposition, oldest is on the bottom, so this dark brown layer would be the oldest. Youngest is on top, so this lime green layer would be the youngest. Okay. Igneous rock formations, this is the other type of rock we're going to talk about. So sedimentary rock layers can be disturbed by igneous rock. So that means something is messing up the consistency of the layers. Let's remember that igneous rock is rock that forms from molten lava. So this happens when molten rock forces its way up through the layers above it. The sedimentary rock has to be there for the igneous rock to cut through. So the igneous rock is always younger than the rock layers that it cuts through. If we look at this picture, we see that we have some sedimentary rock because we have these nice even layers with A, B, C, E, and F, but then D is our igneous rock. So if we think about igneous rock as being molten lava, that's kind of a liquid state of matter, right? So this lava is pushing through layers F and E, but then it flattens out. That means C, B, and A were not there when D pushed through those other rock layers. If C, B, and A were there when D was pushing through, then D would have continued to push through C, B, and A. But instead, D kind of pooled out. So if you think about the igneous rock pushing through layers F and E with nothing on top, when it got to the top of E, that's the sky. So the liquid rock or the molten lava is going to just kind of pool out on the top of layer E, which is what we can see happened here. So if we were to label these in order of oldest to youngest, F would be the oldest, and then E, and then D, and then C, and then B, and then A would be the youngest. Okay, last slide for this video. How else can rock layers be disturbed? Well, the movement of tectonic plates leads to faults. A fault is a break in the rocks that make up Earth's crust, and faults are often associated with earthquakes. So when we think about all of the activities that we're going to be doing this week on law of superposition, we're going to be dealing with igneous rock intrusions or disturbances, and we're also going to be dealing with some faults. So here, if we look at this picture, E would represent our fault or our shift in tectonic plates. If we were to label these rock layers and the fault in order of youngest to oldest, we would see that C is the oldest because it's on the very bottom. B is the next oldest because it's on top of C. A is the third oldest because it's on top, and then D must have been the fourth oldest because it's pushing through layers C, B, and A. The fault or this earthquake or whatever caused this disturbance in the rock layers had to have happened last because all four rock layers were affected by it. Let's say E happened and C, B, and A were all affected, but D continued to go on in a straight diagonal and it didn't look cut, then we would say D happened after the fault because it would have been unaffected by it. But D was affected by this earthquake or this disturbance, so we would say that it happened before this disturbance did. So the disturbance would be the youngest part of this diagram. Okay, I am going to have to record a second video to go over the rest of these slides because I'm only allowed to do a 15-minute video at a time with the software. So this will be part 1 of the notes, and I'm about to upload I will upload part 2 of the notes. Okay, bye-bye.